Welcome to the Unit 4 Part 1 test review. Today I'm going to quickly go over the review problems that you have for your test. So when you are finding the roots of each equation by factoring, remember roots are solutions, x-intercepts, it's where your graph is going to cross the x-axis. So you always want to make sure all of your terms are on one side of the equation and that it's equal to 0. Now let's go ahead and get started factoring. Your values should multiply a times c, so that's 15, and add to b, so -8. The two factors that do this are -5 and -3. And notice that my a is currently equal to 1, meaning I can use the shortcut. So I can say my first factor is x minus 5 and my second factor is x minus 3. You will set each factor equal to 0, so you should get x equals 5 and x equals 3. For number 2, I notice that I have two perfect squares and that they are being subtracted. So you are allowed to use the difference of squares formula. So my a in this situation would be 4x. My b would be 9. So I do 4x minus 9, 4x plus 9, and I should get the factors x equals 9 over 4 and x equals -9 over 4. I would leave them as fractions. You should not be using a calculator, so this is what your answer should look like. For number 3, I have to move over my 3 on the right-hand side, so I subtract 3 from both sides. I get x squared minus x minus 6, so I want it to multiply to be -6, add to be -1. The two factors that do this are +2 and -3. So my two factors are x plus 2 and x minus 3. So I get x equals -2, x equals +3. For number 4, I want to move everything to one side. So I added 3x and I added 1. Now, this is one where the shortcut is not going to work because a is currently equal to 2. So be very careful when you approach a problem like this. A times c is 2. B is 3. So the two factors that multiply to be 2 and add to be 3 are 1 and 2. So I'm going to split my middle to be plus x plus 2x. I'm going to group the first two terms. I'm going to group the last two terms. So I get 2x squared plus x. The GCF for that is x, leaving me with 2x plus 1. And then I get 2x plus 1. The only GCF that these two terms have in common is a plus 1. So make sure that you write that out. Otherwise, you are going to get very confused. And that's going to leave me with 2x plus 1. So my two factors end up being 2x plus 1 and x plus 1. So x should be -1 and x should be -1/2. Shortcut does not work for this problem. Do not try to do the shortcut when a is not equal to 1. For number 5, we are going to do something very similar. I added 5 to both sides. Always check for a GCF just in case. This one doesn't have one, but I do want to remind you to do so. I want it to multiply to be 30, add to be -13. The two factors that work are -10 and -3, so that's how I split my middle term. I grouped the first two and they had a GCF of 2x. I grouped the second two and they had a GCF of -1. My parentheses match. I ended up with 3x minus 5, so that becomes one of my factors. And the other factor is 2x minus 1. So x should be 1/2 and x should be 5/3. And these x values I'm just getting from setting each factor equal to 0. For number 6, I do have a GCF, so I need to pull out a 2 from both terms, leaving me with 16z squared minus 1. Now, this is also a difference of squares. Remember, it's a squared minus b squared equals a plus b, a minus b. So my a in this case is 4z and my b is 1. So I get 2 times 4z plus 1 times 4z minus 1. And if there is no variable with your GCF, it's not going to give you a solution. So you don't have to set it equal to 0. So the only two answers I have are z equals -1/4 and z equals 1/4. For number 7, I do have a GCF of 3, so I pulled that out first, leaving me with x squared minus 6x plus 9. My two factors end up being -3 and -3. Now, because these two factors are the same, this is something that we call a double root. So what the answer is we're only going to get one. We're going to get x equals 3. You could write it twice, but you do not have to. For number 8, I do have a GCF of 2, so I pulled that out, leaving me with x squared plus 7x plus 10. And my two factors, because a is equal to 1, I can use the shortcut. My two factors are 2 and 5, so I get x plus 2, x plus 5. So my answers are x equals -2 and x equals -5. Okay, now we are going to solve the following systems of equations. Remember, with these types of problems, what you want to do is you want to get your two equations to be y equals, and then you want to set them equal to each other. So for number 9, it's already in the form of y equals something, y equals something. So what I'm going to do is set these two things equal to each other. So I get 2 is equal to x squared minus 14. And anytime you are solving, you want it to be equal to 0. So I subtract 2 from both sides, giving me x squared minus 16. And this is a difference of squares. So I'm going to get x plus 4, x minus 4. When I factor, I'm going to set each factor equal to 0. And then I'm going to get x equals -4, x equals +4. And when you are solving a system, you have to find the y value for each x value. Only for systems and only for graphs do you need to report a y value. So in this case, I'm going to write it as an ordered pair, -4, 2, and 4, 2. And I got the 2 from our first equation because it told me that y was going to be 2 no matter what happened. For number 10, I had to do a little bit of work first. I had to get both equations to have y by itself on one side. So for this one, I went ahead and added y and then added 12. And for this one, I went ahead and added 2x to both sides. Once they're in this form, we can set them equal to each other, and we want to move everything to one side of the equation. So I subtracted 2x and I subtracted 12 from both sides. Now that left me with 2x squared minus 8x equals 0. Do not get caught up in this. Always check for GCF first, which this one does have a GCF of 2x, so that's what I pulled out. I got 2x, leaving me with x minus 4. This is a place where students often get stuck. Don't get stuck here. All you have to do is take each factor, and notice that my GCF has a variable, so that is going to be a factor that's going to produce a solution. I set 2x equal to 0. I set x minus 4 equal to 0. X is equal to 0 and x is equal to 4. So what I do now is I'm going to take these two x values, plug it into an equation, and then I'm going to get my y values. I usually pick the easier one. Don't make your life harder and pick the quadratic. Pick the linear equation. So much easier to plug a number into. And I get 0, 12, and 4, 20. For our next example, we are going to be solving quadratic inequalities. So with these, I always suggest drawing a number line because I am able to give you partial credit if you can correctly shade, however you forget to write the interval notation. So what we want to do again is get everything on one side by itself so that I have a 0 on the other side. So I subtracted 6. It gave me x squared minus 3x plus 2. I went ahead and factored this to be x minus 1, x minus 2. Now these two factors are going to give me my critical points, my critical numbers. So I set each factor equal to 0, and it told me that my critical numbers should be x equals 1 and x equals 2. So what I always do is put those two numbers on a number line. Now, if these two numbers are not 0, 0 is always the easiest test point to do. If 0 happens to be one of your critical values, pick one. Pick something that's going to be super easy to plug in. So this one, 1 and 2, I can use 0 as my test point. So I always like to mark it wherever it falls on the number line, and then I plug it into the original inequality. And I get the inequality 8 is greater than or equal to 6, which is a true statement. So I'm going to shade where that 0 value is. And it's always shading outside or inside. It's one or the other. It's never just one side by itself. It's one or the other. So my interval is going to be from negative infinity all the way up to 1 with a bracket because it's an equal to. Union, because I'm skipping over this interval, picking right back up at 2 with a bracket all the way up to positive infinity. Similarly, for number 12, I'm going to move everything to one side, factor x plus 4, x minus 3, get my two critical numbers, x equals negative 4, x equals 3, and that's going to be drawn on my number line. This time 0 falls in the middle, so I always like to mark where it is. Plugged it into my original equation. I got negative 7 is less than 5, which is true. So I'm going to shade in between my two critical points. So my interval answer this time is from negative 4 to 3. It's parentheses because it's a not equal to inequality. 13 and 14, super, super easy. If you are looking for solutions, roots, x-intercepts, zeros, you are looking for where your graph crosses the x-axis. So for us, for number 13, it's at negative 6, 0 and negative 2, 0. And for 14, it's at 4, 0 and 9, 0. Make sure you write your answer to these types of problems as a coordinate point, as an ordered pair. Otherwise, you will not get full credit. And lastly, we are going to practice our completing the square. So first, let's convert to vertex form by completing the square. Then we're going to identify the vertex, concavity, and axis of symmetry. So for number 15, I already have it set up so that I can start my process for completing the square. Remember, you're always going to want your x terms by themselves on one side. Everything else, the y and the number value, should be on the other side. Once you have done this, and once that you have checked a is equal to 1, you can go in and identify my b value is negative 6. b over 2 is negative 3. b over 2 squared is positive 9. What you're going to do is you're going to add the b over 2 squared value to both sides of your equation. So x squared minus 6x plus 9 is equal to y plus 9 plus 9. Then we're going to do some simplification. Remember, after you have added this piece to your x term side, it is always going to factor to be x plus b over 2 squared. And in our case, b over 2 is negative 3. So this is going to factor to be x minus 3 squared. Now, if you are unsure or you happen to forget, this will still factor the normal way. You can still look at this left side of the equation and factor it like we've factored anything else. This is just a shortcut to save you some time. I'm going to simplify the right-hand side. Plus 9 is plus 18. And my final step for 15 is to subtract 18 from both sides because I do want it to be a y equals an equation. Now, for vertex, it's going to be HK. H is always going to be your shift left, right. In this instance, remember, it's always going to be the opposite sign because x minus h is the vertex form, how it's written. So this is going to be positive 3. K is always your shift up, down, so it's going to be negative 18. Concavity is going to come from your vertical stretch or compression, which this equation does not have. So really there's a magical imaginary 1 here, and it's positive. So if it's positive, it's going to be concave up. Axis of symmetry is x equals h. So x is going to equal to positive 3. For number 16, we have to do a little bit of setup. Remember, you want your x terms on one side by themselves. So I went ahead and subtracted 8 from both sides to make that happen. And then I noticed that my a is currently not equal to 1. A has to be equal to 1 for completing the square to work. So what I'm doing is on the right-hand side, I'm going to factor out 2 from both terms. So that leaves me with 2 parentheses x squared plus 2x. Now I can go in and identify b. If you identify b any sooner than this step, it is going to give you the wrong answer. it has to be after you have made a equal to 1. So b is going to be 2, b over 2 is going to be 1, b over 2 squared is going to be 1, because 1 squared is 1. Now be careful, when you've factored out a value, you have to remember when I'm adding to the side with the y, I have to add my b over 2 squared times whatever that factor was. So really, I'm adding 2 times 1. So on my left-hand side, I added 2 times 1. I get y minus 6 equals 2. And remember, this is always going to factor to be x plus b over 2 squared. So I get x plus 1 squared. And then I added 6 to both sides to make it y equals. Vertex for this problem is going to be hk, so -1, positive 6. A is equal to positive 2, so it's going to be concave up. Axis of symmetry is x equals h, so x equals -1. Solving, very, very similar. The only difference is we are going to be using square roots to solve. So let's go ahead and look at 17. First thing I want to do is get my x terms on one side by themselves. So I subtracted 6 from both sides of the equation. I am now going to identify my b to be -12. b over 2 is -6. b over 2 squared is equal to 36. Now I have x squared minus 12x plus 36, because I'm adding b over 2 squared to both sides, is equal to -6 plus 36. Once I do a little bit of simplification, I factor it to be x minus 6 squared is equal to 30. Here is where solving comes in. Now I'm going to take the square root of both sides of the equation. Now, for the number side, you're always going to do plus or minus, because we have to take into consideration it could be a plus in the parentheses, it could be a minus in the parentheses. Squared is going to always make things positive. So when I simplify the left-hand side, I just end up with x minus 6. Simplify the right-hand side. You cannot currently simplify radicals. We are not requiring that you do that. So we are going to leave this as square root of 30. Now, if this were something like the square root of 4, yes, we would expect you to simplify that to be 2, but 30 is not easily taken the square root of. So we're going to leave it alone. I'm going to add 6 to both sides of my equation, and I'm going to get x equals 6 plus or minus square root of 30. Yes, if you forget to do plus or minus, you will lose points for not having both solutions. Now our last problem, number 18. I went ahead and subtracted 5 from both sides. I noticed that a was not equal to 1. So I factored out 4 on the left-hand side of my equation. Now I'm able to identify b as -4. Remember, you have to identify b after a equals 1. So b is -4, b over 2 is -2, b over 2 squared is +4. So I'm going to add +4 into the parentheses of my left-hand side, but really I'm adding 4 times 4. So that's what I did on the right-hand side. That's going to give me 4 times x minus 2 squared is equal to 11. Now I'm going to divide by 4 on both sides of my equation. Take the square root of both sides, plus or minus with the number side. Now remember, when you are taking the square root of a fraction, really you're taking the square root of the top and the square root of the bottom. Now I cannot take the square root of 11, but I can take the square root of 4. So that's how my answer ended up simplifying to be x minus 2 is equal to plus or minus square root of 11, because I can't do anything there, over 2, because the square root of 4 is 2. Last step is going to be adding 2 to both sides. X is equal to 2 plus or minus square root of 11 over 2.